Hello and welcome to this v0.4 version 0.4 video tutorial. And in this video tutorial I'm very quickly going to cover the basic static radiance analysis we can do to calculate lighting metrics within our scene. So I'm starting off with basically the default Blender user interface. Just going to switch to my node editor. I don't think I currently have a node tree within this file, so I'm going to create a new node tree, create my VI location node, which we'll need for a lighting analysis, and that's kind of basic infrastructure setup. So I need some geometry to do my lighting analysis within or on. So I'm just going to take the default cube and just going to create a couple of windows, and I might just now the geometry can be as complex as you like, and if you look on Google Images you'll see plenty of very complex buildings built with Blender, but for the purposes of this video I just want to keep it short and sweet. So I'm going to be using the insert tool to create faces within faces, and these faces are eventually going to become windows. Maybe create one over here as well. And I could thicken that all up. Going to remove my vertex doubles and make sure all my normals are pointing in the right direction. Okay, fine. Now this default cube, it would have come with a material already associated with it. I can see that material, Blender's default material, in my material panel. Now for a lighting analysis I need to specify the characteristics of these face materials, and I can do that within this material panel. And for the default material I'm just going to say it's a kind of terracotta color. That won't update here because this is the material color as understood by Radiance, which will run in the background to calculate the lighting metrics. But I can just kind of replicate that color within the Blender interface as well. Now that's been applied to everything, but I don't want it to be applied to my windows. So if I select my windows, like so, I can now create a new material slot for the object. I can assign that slot to those faces, and within that slot I can create a new material. I can call that window, for example. And down here, instead of now the default plastic material, I can have glass. I could have dielectric or translucent. They would also allow some light into the space. I'm just going to use glass initially. And these settings are in the v0.4 material tab, which generally sits at the bottom of the material tab, Blender's material tab. So that is more or less the absolute minimum setup for a lighting analysis. I can also just make Blender appreciate that those window faces are transparent faces. So that's the general shell setup for the model. So I've got these brown walls, I've got some windows, but I need somewhere to sense lighting level. And again, in a similar way, this is done in a very similar way to the shadow mapping video I did last time, in that any geometry within the scene can be sensing geometry, and we can specify the vertices or the faces of that sensing geometry to be calculation points. But for this example, I'm going to create my own sensing surface. So mesh plane, scale that up, and let's subdivide this edge, and that means I can extrude this edge out. And I might just move that slightly, and now both of these I can subdivide. And now what I'm going to have to do is I can't have one subdivided face next to another subdivided face. So if I just undo that subdivision and I split this edge split, these are now separate faces. Now that has not worked. That's better. It's just a little bit complicated because I'm not doing a square or rectangular sensing surface, but I'm doing what is in effect two separate sensing surfaces. So that's my sensing geometry. And a calculation of lighting will either occur at the face points or at the vertex points. But I'm probably going to set it to be at the face points, at least initially. So in the same way that our shadow study analysis required, we need to specify material for this sensing surface. I might just move that up a little bit, just off the floor. I need a material associated with this plane so that it acts as a calculation point. So new material, call it sense material, and now instead of geometry I pick light sensor. So I'll get rid of my default lamp. So the V-Suite now knows that this is my sensing surface. So I can now, in my process nodes menu, add a LiVi geometry node. LiVi is the general component of the V-Suite that deals with lighting analysis with Radiance. The LiVi geometry node will convert this geometry into a format that Radiance can understand. And we can set a geometric animation here if we want for a parametric lighting analysis, but I'll cover that in a subsequent video. The main options here that will concern us is whether we have the calculation points as the vertices of our sensing faces or the faces of our sensing faces. I'm going to make that faces. Offset is where you have non-planar geometry and you get certain faces within your model that aren't producing, within your sensing surface, sorry, that aren't producing the right results. but all my geometry here is planar, so I can keep that as it is. And I just export that, but it does remind me that I need to save my Blender file. So export. I also need a context node, a LiVi context node, which is going to specify sort of sky context for the simulation. Now when I create this node, a sun gets created within the Blender 3D view, and if I start to manipulate time and day of the year with my location node connected, we should start to see that we get a real-time live update of how the sun is going to move around our scene if we were to do a simulation with a sunny sky. So I'm not actually going to do a sunny sky simulation, or am I? Or maybe I will. So I'm going to make it, put it over there in the morning, a bit nice and low in the sky so we can see it coming in primarily through this window here. So that is fine. I might make it a little bit later in the day. Yeah, okay. So we can set here what kind of analysis we're doing. We can either have a basic analysis, which will do lux, daylight factor, and irradiance, or it can do glare, and I'll cover that in a separate video. We could have also had here compliance and climate-based daylight modeling, but again, I'll cover them in a subsequent video. So I'm going to stick to a sunny sky type, although I have various different sky types that I can select, and you can look up what those are in the user manual. I could set up an animation for the sky in terms of time. So with this option enabled, we could do an animation of the sun tracking across the sky during the day and see the results in terms of lighting for each of those time steps. Turbidity is a sort of atmospheric pollution metric, 2.75 as a default. And HDR allows us to create a panoramic HDR image of the sky that we are selecting here. But that takes a few seconds, so I'm not going to enable that at this moment. So I press export again. That node goes to its default color, saying it's ready. I can now add a LiVi simulation node, which was in my analysis nodes menu. Connect in my geometry, connect in my context, and now I'm ready to simulate. This these frames numbers here tells me what frames Blender's kind of an animation suite as well. So Blender has the concept of frames. We can see which frame we're currently on by this number here, 1. And I can change frame by my right and left arrow. We're on frame 1. This was a frame we're on when we did our export of our nodes. And because I haven't set an animation here or here, the animation range for the simulation is 1 to 1, which basically means we're only going to simulate frame 1. If I was to do an animated simulation, I could set the frames in Blender that I've specified the animation for. So if I put, I don't know, 5 in here, export that, we see now that the animation frames of the simulation now correspond to the animation set up here. But I don't want to do an animation right now. And let me just reconnect that now. And I have to also re-export. But because I've now moved, I set up an animation, even though briefly, I'm now on frame 5. I'm going to go back to frame 1. Export that. export this, and now I'm back to frame 1 to frame 1. So basically I'm only simulating frame 1. Now the preview button would normally allow you to bring up Radiance's preview window, and that will slowly render out the scene from the point of view of Blender's camera, basically so that you can check your material designations and that they are understood by Radiance as you have specified them within Blender. But on recent versions of OS X, we need something called Xquartz to allow the preview window to open. And on this machine, this university machine, Xquartz hasn't been installed, so it doesn't bring up that window. But on Windows and Linux, it should bring up a window, and you can install Xquartz yourself on your OS X machine to allow that window to pop up. We have here an option for photon mapping, which I'll cover in a subsequent video. This option is important. It sets the accuracy for the simulation. Most of these are self-evident, low accuracy, up to high accuracy, and we can specify a custom accuracy with Radiance command line options. I'm going to keep it low to keep it quick for the purposes of this video, but if you're doing an actual analysis, you should be looking at least medium or high for your simulation accuracy or a custom accuracy. So I press calculate, and that was very quick. So the Kiwi window, which I introduced in the last video, didn't even have time to pop up. But it's the same Kiwi window as in the shadow mapping video tutorial. It does exactly the same thing, but on OS X it has a tendency to appear behind the Blender window and not in front. So that simulation is now finished. I can go back to my 3D view, and in my v0.4 display tab at the bottom of my 3D view panel, I have this Radiance display, and in a very similar way to how it operated with the shadow mapping tutorial, I have now duplicated the sensing surface, and within that sensing surface is all the data relating to the results of the simulation. Sometimes when you first create or first press display, this sensing surface doesn't pick up the coloration, and sometimes you have to select a legend color. So I might just make my room wireframe just so we can see what's going on inside. So that's the coloration of the sensing plane based on the lighting that's coming in through the windows, based on this sunny sky. So you can see that this is where my window is. This is the direction of the sun, and we can see that is just coming in and hitting the floor here. So we got a very strong patch of illumination here, relatively low everywhere else. We can see what that coloration means in terms of color with our legend display, and with the sensing surface selected, we can bring up some minimum, average, and maximum values for the chosen metric over this whole sensing object. I can change that metric here from illuminance to visible irradiance to full irradiance. If I had done a simulation with a daylight factor sky, I could also do daylight factor. I can change the maximum and minimum level of the coloration display. So as I reduce the maximum, see more and more of the floor turns red. Same with the minimum number. And that difference should get reflected within the legend, but you might have to put the mouse over the legend to make it update. Same as in the shadow mapping video tutorial, both of these display elements are interactable, collapsible, expandable, etc. We can also do a logarithmic display, which is sort of quite good generally when we've got a big difference between the maximum and minimum value, which we do have in this case. When switching between, oh no, I'll cover that in another video. So we can set the coloration for that lighting data. Again, most of this is very similar to the shadow mapping exercise. The only real difference is we can choose our metric up here at the top. We can enable point visualization of our numbers as before, and change some of the coloration and whether we have a font shadow on our results metrics. So that's you know, pretty much the basics, very basics of a static radiance lighting analysis. It's very quick, so we can instantly, well, we can have a daylight factor sky, export that, calculate that, display that. Now we can see the results from our daylight factor analysis. We can choose daylight factor metric up here, so we can see very quickly what's going on. We can, if we wish, we can expand that window. Now I've changed the geometry, so we have to re-export this geometry. I don't have to re-export the context again if I'm not changing the sky context. Calculate. Now I see the effect of that larger window. I can, if I want, make my plane more resolved, my sensing plane more resolved. That's a geometric change, so I press export again, calculate again. This takes a little bit longer because we now have more sensing points, but it's still finished so quickly the Kiwi window didn't have a chance to appear. Display that. Again, see it pretty quickly what's going on. My 3D view turned on this time. Now switch from log to linear. When I switch from log to linear and I've got this 3D extrusion level, I have to just change the level to pick up that new way of displaying the results, etc, etc. So yes, a pretty quick, pretty easy way, especially when we're talking about very simple geometry, a very quick and easy way to assess levels of lighting within a building. The more advanced parametric options and so on I will cover in a subsequent video. But I think that's everything for now. Thanks for watching.